And welcome. We are back for another 2 hours of Unhindered by Coding. I'm Nick McPhee, and we're returning, as we do on Wednesday evenings, to a project of implementing a simple evolutionary computation system in Rust, and eventually main Clojure, although, yeah, we'll see how things go. So my goal is to have a system, comparable systems in Rust and Clojure, so then I can do timing comparisons between the two. Simple early comparisons of the cost of creating populations of random booleans suggest that Rust runs something like 100 times faster, but that's a pretty simple piece of it. Hello, Izitsu. A pretty simple piece of it. It'll be interesting to see how their performance will differ when we have a full system and not just generating random individuals, and then two hopefully comparable systems. So we had, and I should point out, QR code is linked to join Discord. We've been discussing some different ways to approach some of these issues there, and we would certainly love to have you join us. So the thing that I want to think about a little bit today, and I know Isitsu's had some thoughts on this, and I would certainly love to hear more about that, is trying to parameterize things in a way that's flexible but not overly annoying. And one of the pieces that I'd like to be able to parameterize is the different ways of selecting parents. So we're taking a population, we're selecting parents, we're recombining those parents, mutating those parents to generate a new population of children, and we want to keep doing this until we run out of time or find the answer, whatever our goal is. And, I had played around with some simple things. So this just chooses a random individual. I implemented a best individual that chooses the a best. There could be multiple with the same best score, but chooses a best. And I would like to be able to parameterize this in a useful way. And then there's the question of constructing the new bit strings from those parents. And I'd like to be able to be flexible about, I'd like, 25% to happen through this mutation and 50% happening with this combination of crossover followed by mutation, and another 25% happening with crossover all on its own. So I'd like to have some kind of flexible system like that. That's actually really easy to do in a functional language. Well, especially probably wouldn't be all that easy to do in like Haskell, but a loosely typed language like Clojure, it makes that kind of thing quite straightforward. So question is, what is that going to look like in a very aggressively strongly typed programming language like Rust? And so we had some discussion last week, and then some discussion on Discord, and my inclination, unless somebody wants to jump in and be like, no, don't do it, my inclination is to try to do something. So I'm going to focus first on the selection question and try to deal with that in using iterators in some useful way. So if we hop over here to population for a second. So population is a struct containing a vector of individuals, and we have a new method that constructs new individuals. And really, I should just get rid of this comment to code because that's old news. And at some point, if somebody cares, we could talk about this R. type. That was very weird and actually I had to go to the Rust users group to figure this out. And so that was a trip. But so we implement new, and we implement this best score method, which just uses max by key to find the best individual, or a best individual in the population. And I'd like to have some kind of selection thing happening here. And I feel like the way, based on the discussions last week and online, I feel like something involving iterators is the way to go. That what would be nice to have is I'd be able to say, here's some different ways of doing selection. Choosing the best for elitism, choosing randomly for diversity, choosing with some kind of weighting toward the best, so there's some selection pressure. Some combination of selection operators, and be able to say, I'd like 10% of the population to be selected using this, and 80% using that, and 5% this, and 5% that, something like that. And then have it do the thing. And have it then build an iterator that returns an infinite, right, sequence of individuals chosen using this weighted collection of selection operators. And I feel like that actually, it gives me a nice pipeline. I ought to be able to sort of say, here's the ways I want to select. I get an iterator out that I can take that iterator and I'll be able to pass it around to various people that need parents because they're doing selection. They're doing recombination or mutation, Selection will have already happened. And they'll be able to take that iterator and say, oh, give me 2 things off of that iterator, or give me 1 thing off of that iterator. So I feel like an iterator gives me kind of the pipeline I'm thinking of. The other option that I've thought of a lot is to use channels, which in some ways I think is actually, I don't know if I will say better, but I think it's certainly interesting and has a whole lot of potential, but it also complicates things a lot, whereas iterators are fairly straightforward and will map, when we get to the closure universe, fairly nicely to lazy lists. And so I think there's sort of a natural mapping there when doing the performance comparison. Closure also supports channels in a nice way. So if we did a channel implementation in Rust, I think we could do a channel implementation in Closure, and that would be spiffy. But I think for the moment, I'm going to stick with trying to do this first, at least with iterators, and see if we can get things to go that way. So I'm going to start out by dropping these things in the population module. I may wish to move them out into their own selector module at some point in the future. Now, I think I don't want... Well, actually, this is interesting. I was thinking about these as standalone functions, not methods in the population type. But clearly, at some point in the past, I did this as a method in the population type. Because what I was thinking, I think, was something like type selector equals fn reference to a population of t and returns a reference to an individual of t. So something like that. And that fails because, I didn't actually put the t here, which it needs. And now that fails because this needs to be dine. Because, there we go. Okay. So I'm thinking of a type like that, and that I would have a function which maybe would just be a method in population, now that I think about it. Probably makes more sense. Let's put you there. Yeah, we'll put you there. And I'm going to put this in its own impl block. I don't know if I want to keep it that way, but for now. And what I want to do is build a selection iter. So fn selection iter that's going to take a reference to self, and it's going to take a collection of selectors. So vec selector t, and it's going to return an iterator something like that is what I'm thinking about. Now that doesn't work. You have to have names for things, don't you? Selectors, and we need a dine in front of this guy. Oh, we need the type, actually. That's definitely going to need to happen. Item equals individual, reference to individual t. And then we need a dine because we're returning a trait object. And now this doesn't have a size. That's awkward. Oh, I think if I made that a reference, which I want anyway, no, that did not solve the problem. So what is the actual issue? So vec selector t doesn't have a size known at compile time. The trait size is not implemented for the fn. Oh, I want a vector of references to the selectors, I think. That did not fix anything. Oh, it did. It moved the lump. Now the problem's over here. The size for that cannot be known at compile time. Well, that's not helpful. Oh, come on. What is my problem? Oh, yeah. Thank you. Now, how would I have known that? So I need to impl, and I did. Part of me did know this, and now we're good because we're just not returning the right type. So that's actually totally correct. Now, how would I have known that I needed an impl instead of a dyn here? I guess I just need to know that this is a trait, and when you return, you don't return a trait, you return an impl of that trait. And if I came back to here, would that have given me some kind of feedback that would have told me that? Yeah, see, it tells me I want a dyn, but I really do want an impl. So I'm going to return something that implements iterator, but we don't know what that something is yet. And that's why it was being fussy. Okay. So what I want to do then is to return something that implements, hence the impl, the iterator trait. Now I could do that kind of by hand and have the type and the next function, but there is, because I was doing some homework, Rust iter see, I think it found this to be a useful place to go. From fn. So from fn lets you construct an iterator from a function that generates the next value in the iterator. And that seems like that's exactly what we want, because we want to use this collection of selectors to generate the next iterator. So I think we can do just return a std iter from fn of the right thing. From fn, we'll use that, and that takes a closure. We're going to need to use, oh no we don't, because we've got self here, so we will need to, is that right? Yeah. We'll need to use move so that self and selectors are available inside the closure. And then we're going to want to randomly select a selector. And at the moment, I'm going to choose them uniformly. Down the road, I think we want like a weighted distribution. And I think there's a crate that provides that weighted distribution selection thing. But I don't want to complicate the world with that yet. We'll get there. So I want to have let s be selectors.choose rand thread RNG. So that should choose the choose a selector at random from this selection or this collection of things. And then, I think I need to import something. I think I haven't imported Rust rand choose slice random. That's what it is. Rand seek slice random. So that actually importing slice seek. Where do I want to put that? I'll put that here. Use slice seek. What did I want? Slice random. Oh, rand seek. Seek slice random. Boop bop. That basically adds things to slicey stuff, which includes vectors. And so now I ought to be able to call choose on selector. And it's grumpy just because we're not returning. I guess actually if I added none here, that would actually make it be quiet, except it's fussing here. Oh yeah, we have to and mute it because we're passing that in as a mutable reference. And now we're fussy about something else. What are we fussing about? Oh, lifetimes. Oh, happy day. Okay. Yeah. So, now it says I can just add the anonymous lifetime to the infiltrate. I don't think that's going to be my preferred option. But let's see what happens. Oops, come on. Lifetime may not live long enough. Yeah. So we should think about the lifetimes for a second instead of just hacking away. So we're returning an iterator. And that iterator depends on this vector and the population, because this iterator uses selectors. So it's the iterator, as long as the iterator lives, the selectors need to live, and as long as self lives, we haven't gotten to using the selector yet. But as long as self lives, then we're going to need to care. And so I think we can do I wonder if that would go there. Oops. So here we're saying, oh, hey, look. It looks like it compiles. Is that true? That's craziness. Yeah, it does. Okay. So we're saying that for some lifetime A, the population will last as long as A, and each selector in this vector will live as long as A. That if, I guess I should say, if both of these things are true, if the population lives as long as A and each selector lives as long as A, then we will get back an iterator where the items that it returns will live as long as A. And that will hopefully be okay. So we've selected, oh, and I guess we've got an option here because choose returns an option. I probably want to unwrap that, but I think I want to have an assert bang that selectors dot is empty. Ooh, that didn't do the right thing. Empty is false. So I need to make sure that selectors is not empty. If that's true, then choose will always succeed, and I can just unwrap. That'll be awesome. Now I want to actually use the selector. So the selector takes self and returns it. Oops, got it. And I think, oh, didn't like that. Oh, right, because an iterator returns an option. So I think maybe I want the selector to return an option. That might be simpler. And maybe there could be circumstances. Oh, yeah. Could I use question mark? Yes, I could. Thank you. Because this returns an option, then if this failed, we would just return none. And I kind of think I might just do this. And now that actually compiles at least. And then in theory, we ought to be able to oh, you're right. Good catch. Now we don't need the assert because we will just return none if, and I don't really need that comment to remind myself what I was doing anymore. So we ought to be able to create a vector of selectors and oh yeah, thank you. We don't want that to happen over and over again, do we? Good catch. Ran thread boom, and then this would be and mute range. No. Oh, that's because this needs to be. Yeah. Okay. Nice. Thank you. Good catch on both of those. So now we should now be able to pass in a vector of selectors and get back an iterator, which we can then use to populate to be the parents. So if I come back to here and I've got this, oh, and actually maybe it would be useful to give myself a choose over here. I could say pub fun random self individual t self dot individuals dot choose rand thread rng dot. Oh, I want this to return. Oh, yeah. So I want both of these to return an option. Actually, that's going to break some stuff somewhere. Why is that not happy? Oh. Okay, hang on. Operator cannot convert from individual to option individual. Oh, it's because I don't even need the question mark anymore. That if I make this an option, then I don't need the question mark. Now, why is it grumpy about this? Oh, because I need the and mute again, because I never remember that. Yes, we're passing that in that way. And now we would change this to be an option. That's going to blow up a bunch of stuff somewhere else. We're going to have to remove that. But now we don't need the unwrap. In fact, let's just put this all in one line because this doesn't really need to be. Now that's going to break some other stuff, but it didn't appear to break some other stuff. Was this just never being used? Possibly. Maybe I never got around to using this. But now I ought to, let's see. This doesn't panic anymore, so that comment is no longer accurate. And now, if we come back here, oh, I think this was me playing around with some of the same stuff. But we never got to using it. Oh yeah, we had all this stuff back here. Where I think we were, my selector was this super complicated thing. Oh, I wonder if my selector should take the RNG though, so that we only have to get that once instead of although actually we only do it once here when we build the iterator. So that's probably okay. Although, okay, and question is par-iterator. How does that work, and what do we have to do to use it if we want to implement that trait? Rust rayon par-iter. So it has an item send, and the required method is drive unindexed. You should not need to call this directly. Causes the self to start producing items and feed them to the consumer one by one. It may split the consumer before doing so to create the opportunity to produce in parallel. I don't think I want that. Now that takes me traits for writing parallel programs using an iterator style interface. Typically all you have to do is convert the first iter method into par-iter. But if I'm implementing the iter method, then that's not going to work. Does selection need to be in parallel? Not critical. It would be nice, but I don't think I want to get bogged down in it quite yet. I am going to make a note though that this iterator is sequential, and we might want it to become parallel if that is feasible. I'll need to better understand how to implement Rayon's parallel iterator trait. Okay, I think we'll leave that like that. So for the moment, I'm going to leave this this thread RNG here. To do, we might want to move this want or need to move this somewhere else if we add or convert to parallel iterators. Okay. So, oops, I don't want that. I want this. So I'm actually gonna, what am I gonna do? I'm going to, I'm gonna like comment all of this out for now, just so I don't get too confused about what's going on. And see if we can change next generation to use selectors. So right now next generation is just doing this crude thing, and the idea was to see if we could rewrite it. Pub the next generation with selectors. That's going to take a reference to self. It's going to take a collection of selectors, which is going to be a vec of reference to selectors. Yeah. And an RNG. No, it doesn't take an RNG. It takes a compute score. Oh yeah, and I really should give this whole mess a name because that is gyros. And it's going to return self, and we'll say to do. Okay. Oop, I lost. Oh, that's supposed to be in. It really ought to be in the impl block, right? Oh, I guess I'm just floating this out here in space at the moment. Because I don't have. So you could close that. So this really, this just shouldn't be here. And this whole thing, is this in an impl block? Oh, it is. Okay. Yeah, fine. So then, really, why don't we move you down here and scoot you guys over. Okay. Now, we don't know selector because it's not accessible, because I didn't make it pub. Pub. That will take care of that problem, or not. Oh, I need to import it. Oh, come on. Yep. So now up here, we should have population gets a population and a selector. And that all compiles. No, it doesn't. Oh, because we refer to T here. And aren't we in a population of T? Oh, it's a bit string. Right. So this is sort of hard-coded for bit string. We'll go ahead and say that then. I don't want to do that. Or do I actually want this in population? I think I do. I think I want this to be in population. Well, no, because the crossover stuff is still going to be bit string specific for now. Yeah, okay. So we'll keep doing this. So we're going to get our set of selectors, our compute score, and then we're basically going to steal all this, but replace the selection-y bits with our iterator. So we're going to want that and that and that. Going to want all of those guys. And we're going to want to build that set of iterators. So let parent iter be self dot, what did I call it? I called it selection iter, which needs to be pub or it's not going to be visible. Self.selection iter, and it's going to take the set of selectors and it's going to return our iterator. Okay, that works. Now we're going to steal all of this down to here. We're going to have to make some changes, but I think we'll, and everything from here to here needs to be indented. Okay, so we're going to go over the pop size, turn that into parallel iterator, map init. Going to pass in the random number generator as the init part. The operator is going to take the random number and our location, and I'm going to skip the size. In fact, I think we'll just turn this into an underscore because I don't think I'm paying attention to the index. And I'm going to say we'll continue with this hacked up recombination for now. We'll just say that let first parent equal parent iter dot next dot unwrap, and let second parent be parent iter dot next dot unwrap, and then we'll just come down here, scoot that guy over, and lose this part. And something's not thrilled. What is unthrilled? Oh, expected unit. Oh, that's because I need to return population there. Something is not happy. Ooh, wow. Okay, let's go to cargo build. Absolute clear. So rand thread RNG can't be shared. Oh, it's actually because of the selecty thing. So it's getting captured by this move, and that's causing a problem because this could happen this is getting made out here, but it's getting called in different threads because of the par-iter. And so where we capture this out here actually could get us into trouble. Now, if I move this into the from fn call, which we had carefully moved out, does that actually fix the problem? The option cannot be shared between threads safely. Ugh. Okay, let me actually come back here. Clear. Oops, nope, not that. So this function cannot be shared between threads safely because it doesn't necessarily implement sync. So that type that I made over here for a selector, that needs to also implement sync, and I bet it'll need to implement send. Cannot borrow parent iter as mutable as it is not declared mutable. Oh. Let's take that in and make that mute. And cannot borrow it is mutable as it's captured in an FN closure. Oh. So the FN closure is capturing the iterator? Is that what that's saying? It's captured in an FN. It is captured in an FN closure. Can we just pass mutable reference? Is that even a thing? No. Cannot borrow is mutable. As capture an FN closure. So that the only FN closure. So parent iter is the iterator. Oh. So map init is FN, so you can't mutate anything outside of the closure, but this needs to be mutated, which is why this was here in the first place. So to set this up, so do we need to set the iterator up here as well? And will that happen multiple times because of the parallelism now? So I think we want this to happen multiple times because of the parallelism, because we want a different thread RNG for every thread, but we really didn't want a different iterator for every thread. Is there a map mute init or something? Rayon map init. Map init. Map width. No. Oh, go away, go away. So map init applies map op to the value returned by init with each item in this iterator. Produce a new iterator with the results. So init gets called every time. Is that what we're using? Yeah. This isn't a closure. Yeah, you're probably right. A map init mute would probably break the parallelism. So do I have the two vertical bars here? I don't. How do I get away with not having a function there? Oh, because this is a function without the parentheses. If I added the parentheses, then it would be not a function. So we are doing a function here. And we don't want, if this is returned by init with each item of this iterator. So it's going to call, the init function will be called only as needed for a value to be paired with the group of items in each rayon job. I'm not sure I understand how to read that. Is that saying that, because this makes me, applies to a value returned by init. So it doesn't, I think it's saying that it won't necessarily call it init over and over and over again for every item, but that it will only be called as needed. And so we could make a new iterator for every thread. And I don't actually have a problem with that, because they'll all have their own random number generators. And constructing that's not that big a deal. So we could probably have this closure return this and the parent iter, and then that would resolve this problem, I think. I'm going to turn this light on. It's gotten dark. And it's so important that you all see my lovely face. Well, let's try that. Let's see if we can make that happen. So I'm going to comment this out. I'm going to say this is a thing that's going to return a range. We're going to go ahead and call it. And we're going to have self.selection iter selectors. Boom. And now this is going to become range and parent iter. And no, we're not happy. Cannot move selectors because it doesn't know how to copy that vector. and it might need it multiple times, because now instead of calling this once, we're potentially calling this repeatedly. Can we make this a reference to the vector and then we would have to change this to be a reference, because we don't necessarily need to own it. In fact, if we're going to share it across threads, we're going to have to not own it. And now there's a lifetime trait, because we don't know how long this reference will last. Oh, poop. Well, I think we could say this reference will last as long as the population lasts. That would seem reasonable. And that seems to make that go away. And then this now compiles. Yay! That's kind of exciting. So we are going to end up, make a note, this ends up creating a new parent iterator at least once per thread, and possibly more. Might want to add some debugging or some print statements to see how often it gets called. Okay. So in theory, that will allow us to construct a generation with a set of selectors. Now, who called this? Go to references. Okay, so back here in my main, we called next generation. And so we now want to call next generation with selectors. And we want to pass in our selectors and our score. And our selectors, oh, we don't want to do this over and over again. We want this to happen once out here. Selectors, we want this to be a vector of functions. Can I just say population : something something? Best score and random are the two that, oops, main. Best score and population random. Is that syntax? Hey, it worked. No, it didn't work. I didn't think that was going to work. That just seemed super unlikely. Expected struct box of fn found box is the problem that it's a vector. I'm making a vector that's got two different things in it as far as this world is concerned. So even though they implement the same thing, they don't have the same. Oh, I see what you're saying. Yeah. So you think if I make these references, no, still not happy. Yeah, I think there's a problem of it's going to need them to be the same thing. If I'm going to write, so I think I have to like declare this to be a vector of type selector and then push the things onto them as imply things. So you think it should be okay, just understand that they should be andine. Is that a, like, I need to specify a type here? That does need a T, right? Oh, no, it just isn't even imported. Now it's going to need, yeah. Syntax error one. Oh, I'm missing a third close thingy. Oh. Did that fix it? Looks like maybe it did. That's not happy down here, but it's a different kettle of fish. So that's supposed to be a reference. So take a reference of that. No, that did not fix the problem. These types get insane. Expected a vec of references to functions, found a reference to a vec. So it didn't want the ampersand there, but I thought, well, did next generation with selectors not take a reference? Oh, it didn't. It's set to, oh no, it's a reference to a vec. So what are you grumping about? Expected vec reference fn yada yada yada, found vec reference so just selector bit string here. Oh, you're right. It's good catch. Okay, and I bet if I looked at this, population vec bool, population individual vec bool. Yes. Because all we parameterize on is the underlying genome type. So that makes sense. Now we're unhappy because of a move, and maybe this is where I wanted the ampersand, because I want the reference to the no, it didn't want the ampersand. So let's look carefully. A captured variable in FM mute close move occurs because selectors has type, which does not implement copy. So yeah, so change this to be a. But this does. Oh, no. Where's. Well, that was over here. Gotcha. So this needs to be a reference here. And now that may mean I've got too many referencey things. Maybe not. And then this, I do make that a reference. And do we compile? We might. Oh, could be. Oh, we compile. So now, in theory, if I run this, it'll work. Cargo run. Okay. That was a happy thing. Let's actually, for fun, b top minus lc. Are we? Yeah, we're making all the CPUs hot. So that's a win. Might be messing up the stream. I hope I'm not, by running this, I'm not causing the stream quality to go all to pot. But it did seem to use all the somethings somewhere, so that's a good thing. Now, I do think I want to quickly see how often. What was the thing I was concerned about? How often the selection iter was called. So I'm going to say print line bang. We're calling selection iter. And whoa, we call it a lot. Are we calling it every time? That would be super annoying. Grep selection, can't spell. So we called it 42,000 times. That is not good. Don't really want to call that 42,000 times. Really just want to call it once. Which means, I think, selection iter needs to take the RNG as an argument, because that's the mutable thing it was capturing. So I think if we pass it the RNG, then we can avoid this whole business, he says optimistically. But actually, no, hang on. No, because we can't pass it the random number generator. Because the random number generator, yeah, because we want to call this once, not call this every time we select a parent. So iterators are inherently mutable. So if we're going to parallelize, call this in a parallel setting, so I assume by chunking the par iter, I am being explicit about how I want Rust run chunk par iter chunks. Splits an iterator up into fixed size chunks. Returns an iterator that returns vex of the given number of elements. See also par chunks and par chunks mute. Returns a parallel iterator over at most chunk size elements of self at a time. Chunks do not overlap. That's not messing things up for you folks. So chunks returns an iterator, but doesn't do it in parallel. So then the hope would be that every chunk could be handled separately, and we would only create the parent iterator once per chunk instead of 42,000 times. Downside of this is that I have to specify how many chunks that I want there to be, and the par iterator was nice because it did that part for me. And I didn't have to think about that. So this would work, but now I've got to, like, if I'm going to be smart, I probably have to do things like ask how many cores there are, and then pick a number of chunks related to that, which is part of the whole happiness of having Rayon do all that work for me, and now I'm sort of doing it myself. What is parse split? It's a parallel iterator over subslices, separate. I don't know. I'm not trying to do that. What is par windows? Parallel iterator are all contiguous windows of length, window size. The windows overlap. So that's just the flip side of par chunks. Like you do some division and you could switch between them. So in one case you are... No. Oh, the windows overlap. No, they're not. Not what I said was wrong. Par chunks and par windows differ in that chunks guaranteed to not overlap, and Windows will. Well, that is irksome. I hadn't really thought about the parallelism problem. And this would be a place where channels would be definitely better because they are built with parallelism in mind from the ground up, and it would not be that hard to do things in parallel with channels, but it would be a substantial rewrite. I wonder what the performance difference is. So if I stash what we've got here, stash, and confirm that things still run, they do. Now, if I make, I probably want to unstash and make the benchmark. No. Do I have a benchmark for running the run? I do not. I only have benchmarks for constructing things. So I probably do want to add a benchmark for main, and then I can run it, undo the stash, rerun criterion, and see how this changes the performance of the world. Let's do that. Okay. Can I call main? Oh, and these don't even compile. Oh, best score, so I'd have to say unwrap and unwrap. And no. I take it back. Need to pay more attention. Read more carefully. What was the fuss? Okay. So why is it? It's not complaining. I don't know what happened. Okay, it was fine. So, can I call main? Or do I need to move? Oh. So is the concern that when I restore the stash, I will overwrite the... oh, I see what you're saying. The red underline was old Rust analyzer cache. Yes, bingo. Thank you. I get it now. So... can I call main like a regular function? I guess I can. I don't know why I couldn't. So, so fn benchmark main, I'll say if cmute criterion, can't spell, c.benchmark function, run main, on if, and then actually let's do that. This is going to need to be take a bencher, and we're gonna be iter main. Oh, and no. Oh, I didn't need to actually provide a type. That'll simplify the world. And it claims that's going to work. I'm going to have to change this to construction benches and criterion group main benchmark main if, oh, it can't spell, mark main if, boom, boom. Oh, this needed to be here, and that needs to have main benches added as an argument. So I think that will work. He says optimistically cargo bench. Now we wait for stuff. Oh, quite a lot compiled. Hi, alveol. So I don't know. Constructing the selector may not be that big a deal. Now, constructing 42,000 of them doesn't seem great. Population size was 1,000. There were 100 generations. So we constructed a selector like once for every 2 individuals, which is a lot. And if there's any cost in that, that is not going to be fun. Not thrilled about that. But we'll see. Maybe it's not really that big a deal. Come on. Okay, we're actually running the benchmark now. Probably should have actually skipped the commented out the construction benchmarks, because that's going to take a while, and it's certainly eating up the CPU. So I don't know what that's doing to your experience on the streaming side of things. Okay, here we're running main. So 600 microseconds. Oh, that was still construction. Wow. Oh, did I miss a print somewhere? Forget to change the name of something? Because I think that is Yeah, I think I must have left a name wrong, because I'm guessing that this 600 is the answer that we're looking for. Why are we going around and around and around? We should be done by now, right? Have I done something to create an infinite loop? Oh, yeah, that's probably right. Where I refer to main here, I'm probably actually recursively calling the benchmarking code, not the right version of main. Yeah. So this probably generates the main that I wanted. So I really should probably pull this out into a function. Do main, because that's a terrible name. Do main. And now this, if I change this to do main, and now we're going to have to find this, and that's going to be in and I didn't make it pub, so it's not. Without it being pub, it probably wasn't even visible outside of the world. I don't know. Okay, what if we comment you? So you say it shouldn't be visible in a bin either way. Oh, so this needs to be in the lib side of things. Okay. So actually, if I just take this and put it here as a cheap hack, really I'll have to clean that up later. Oh, many imports are going to be needed if I do this. And not too many, just two. And this is going to have to be going to work? No. Oh, it's private. Because when I copied it over, I left out the pub. Okay. That all compiles. So we come back here. And we import that like that. Oh, I guess we didn't need that because it did it down there. Okay. So now everything compiles again. And hopefully... Oh, and I'm going to actually remove I'm going to leave these guys out. So we just do the main benches because we don't really want to take forever. Oops. No, stop that. Okay. Now hopefully not have the infinite loop of weirdness. Oh, is it going to print all of this every time? That is going to be not great. Yeah. So we need to take the print out. That's weird. Because I thought when I've run stuff like this, I thought it didn't actually print it. But maybe I'm wrong. Let's print. No, let's not print anything. I mean, we're doing benchmarking, so you're really not supposed to print stuff. Yeah, I hope that there's not. I'm a little concerned that there'll be some kind of compiler optimization that will recognize that nothing matters anymore and stop doing any of the actual work. But I guess we'll tell if it's like super, super fast. That would suggest that it has decided not to do any work. And if we look over here, we are using all the CPUs. So that's good. So it does seem to be doing something. Okay. 134 milliseconds. Now, if I bring the stash back, actually, I wonder if I want to commit this or not. So this, oh, hang on. Am I looking at the stash? Yeah. So that moves that into there. Do I want to commit this? Probably not. Let's just pop the stash and hope that I get one conflict. Prevent stash application. Which means I think I do need to commit this so it can do something sensible. Well, that's annoying. Okay. So what have we done? We basically moved the main into lib and created a benchmark for running main. Moved the body of main into lib and created benchmark for main. May want to undo a lot of this, but this moves main, the body of main, into a do main in lib so we can benchmark it. Boodly-doo, da-da-da-da. Now, pop you. Do it. Okay. File conflict. Oh, whiffy, biffy, 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 biff. Oh, right. All of domain's going to have to get switched. Well, let's go with this. And we will then move that again. Now we we should have the new version of the world. And let's see, main's over here. So this needs to be copied, cut, do main, and this needs to be replaced. Actually, I'm gonna keep the other one just for fun. So that'll be the prehistoric one. And now we got a few more imports we're going to have to do. And then this is going to be this is broken because now it is an option. So now we do have to unwrap these. And okay, so everything compiles again. So we were at 134. Let's try running it again. Oh, we still have the print statements. That's going to be over here in do main. Oh, and actually main's not happy now. Why is main grumpy? Oh, because we have to import that. Okay. Nope, not happy. I thought I just told you to do that. Okay, now. Doodly doo, doo 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 doo, bum 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 bum. Come on, you can do it, little computer. $135, so about the same. Probably not a statistically significant difference. So let's see. Open benches. No, that's my code. Open target criterion report index. Run main on HIF. And so there's the comparison of the two of them. And the distributions look almost identical, with blue being the new one and red being the old one. So the new one has a bigger hump here, but red's actually more out to the right. Although I don't know that we're getting a huge number of samples. There's a warning here about unable to complete 100 samples. You may want to increase the target time or reduce the sample count. So we're probably not getting as many samples as we would have liked. But still, the net view suggests that the two behave more or less the same, which suggests that while running, so you want to be in bit string, while calling this many times is not optimal, it isn't killing us. Which is in some ways not super surprising, because this really just creates a wrapper around a closure. So it does very little actual work compared to constructing and scoring all those individuals. So I'm not super happy about it. Well, actually, one thing this tells us is that building an iterator here is largely nonsense, because we construct this iterator so many times that we never take very many things from it. It doesn't really act as an iterator in a meaningful way. I wonder if implementing iterator then is the wrong thing to do, and that we ought to just iterate, or just have a trait that says, give me a random parent but it's still going to have, whatever it is, it's going to have to be different in every... No. Because it could take... Yeah, so the next in the iterator trait can't take the random number generator as an argument. And that's the mutable piece that has to vary across threads. If we made our own trait, we could pass in our next, which we could call next, whatever. Our next could take the random number generator as an argument, and then we wouldn't have to worry about it being mutable across threads, because the mutability would be captured in the random number generator, which would be passed in as an argument. He says, sort of thinking he knows what he's talking about on that front, but possibly wrong. Yeah. So maybe making it an iterator wasn't the right thing to do here. Right. But I think if... Where am I going to be here? I think that if we... So what my vision is, if I bring this back to this, and bring this back to, I don't know, a something or other. We'll keep calling it this. And it calls next, but it takes RNG here. Then we'll have a bunch of different RNGs, one for each thread. But when we call this thing, which is no longer an actual iterator, but a thing of our making, ParentSelector, or I don't know, whatever, it will pass in the RNG, and that will be the one piece that gets passed in that is specific, that is thread specific. And so we only have to construct this once with the population and the selectors here, and it would take the RNG as an argument, which would allow us to share a reference to this thing, because it wouldn't need to be mutable anymore. Like that would go away. And we could just pass a reference in, and so every thread would be pointing at that reference, and the difference would happen as a function of the argument instead of something that's encapsulated. So the problem, I think, was that, what we were doing was encapsulating the random number generator, and in the iterator, and that breaks sort of passing it out across multiple threads. But if we extract the random number generator out as a parameter, then I think we can call and pass the random number generator in everywhere that we need it to be passed in. Yeah, so maybe more of a get than a next. And so iter's a bad name. If we change this to, actually, before I do anything, let me commit what we had, because what we had worked. And I think I want to save that before I start messing around. Why are we... Oh, I'm missing that one. Okay. So let me everything compiles. Let's commit what we've got. Stage everybody. So this creates the selectors stuff. And that just moves that over. And okay, so this adds an iterator that is built on a vector of selectors, functions that select an individual from a population. It turns out that we end up constructing our selectors nearly once for every 2 parents or individuals created. And it wasn't terribly inefficient based on the criterion benchmarking, but it still annoys me. That's probably not great, but so now I want to redo what we were doing. Okay. Oh. Somehow. Oh no. Oh, I forgot that this also needs to be turned into just that. And then I want to rename this. parent selector, boom. And I think, yeah, I like get. Let's go with that. Now this blows up the world because none of that exists. So self-selection iter. Let's go to that definition. Why don't we just rename this parent selector? And it's not going to return an impl iterator. It's going to return a really it's just returning a function, but we could define a no, I wanted a trait. Trait parent selector. It's going to have a function get that takes a thread orange and returns a, well, we'll go with the option part. That means this is going to have to do this. Oops. And this is grumpy. Oh, do you actually have to say the? Apparently do. And we're going to need to have some lifetime action. So as long as that parent selector exists, actually, do I need a trait here? Yeah, I do. I want, because I want to return something we can then ask for stuff. So I think that makes sense still. So the individual should last as long as the parent selector lasts. And then this is going to return you'd return a struct here. Probably you mean down here. Because the parent selector is going to have to hold on to stuff. Yeah. So really, so this is actually a struct, and we're going to have hold some things, and then there's they're going to be an impl block. Oh, stop it. So this is going to be like an impl parent selector, and it'll have the get method in it. So parent selector is going to hold a group of selectors, which are a reference to a vec of references to selectors of type T. And that means, we're going to have lifetime. So probably going to need all that lifetime stuff that was there. Oh, it's not semicolons, comma. And it's going to need to have a population. A reference to a population of T. And then this thing is going to need to be that. And this is going to be a parent selector of A and T. Oh, gotta have impl A T. And then this get is going to basically be the body of this thing. So we'll say let S be selectors, oh, be self dot, and I'm missing an equal sign, self dot selectors dot choose mute RNG, which means this is going to have to be and mute RNG, or we're not going to be able to get it. I did my syntax wrong, didn't I? It's the and mute's on the other side. And mute. One of these days I'm actually going to get good at Rust syntax, and then I'm going to be useless everywhere else, I can tell. Oh, and we need to take a reference to self, or this doesn't work. Yeah. Okay, that's better. So we do the choose, and then we say S of self dot population. And S is not happy. Oh, there's a question mark here that I left out. And that all compiles. So this is going to return something that implements ParentSelector. Actually, it just is going to return a ParentSelector. All this impl stuff's going to go away. I do have to have the generics. I bet I don't need the A. And then this is, I need a constructory thing. Fn new is going to take a population. So new is going to have a T. Probably going to need an A. And a selectors. Which is going to be a reference to a vec of reference selector t. We're going to return a parent selector population and selectors. Oh, and I have to say and return self. Right, that should be a reference to a population. And expected population T. Oh, there's a T up here. So that new didn't need a T. Yeah, okay. So now we ought to be able to return a parent selector new self for the population and selectors for the selectors. Does that work? This file compiles. That's exciting. And I run a little after 9, but I'm like, oh, I feel so close. Now, this is broken. Why is this broken? What? So you think this is causing the problem? The size for values of type array of bool. Where is their array of bool? Individual line 11. Well, that's just where this is declared. That's really okay. Let me see if we get something more useful here. That's, okay. So that's not used anymore. That's fine. This is a private associated function. Oh. Well, I wonder if that's fundamentally the issue. Where's my get? There we go. So actually that probably, I don't know if it needs to be pub. This one does though. So we call that outside in the world. Expected. We're not calling the random number generator. That's no. Oh, thank you. Yes. What? Yes, that definitely was broken. Now we're back over here. We need some lifetimes. type of the population. So we need probably that's going to be an A, and that's going to be an A, and that's going to be an A. And this, it isn't happy. Cannot borrow. RNG is mutable. Oh, because we set it as and mute up there? Is that the issue? This is private. What is the deal? ParentSelector is declared as private. So this pub, the struct needs to be pub. Is that everything compiled now? That would be kind of weird. Looks like it. Does that mean it works? I don't know. Cargo run. Oh, I've got the print statements are missing, commented out, so we won't know if anything actually happens. It runs. Now, that was an improvement. If we come back here, the hope then is that this gets called a lot, but that only gets called once. Whereas before, we had that ParentSelector being constructed over and over and over again. So actually this to do could go away. Now we should probably benchmark it again. And then we should quit because it's late, tired. Let's confirm that this still runs. Of course, we won't be able to see anything, but all my cores got hot. So, cargo bench. My fans are all hot. Actually, my fans are all going because my CPUs are hot. I probably should change that target time thing. But 134, that's almost exactly the same as before. And if we reload this, yeah. So we did not meaningfully change the performance by making that change, but I do feel like it made this bug me less, especially knowing that it compiled so many times, or that it ran that ParentSelector thing so many times. So this, we should wrap up here. Cool. I very much look forward to seeing what you've done, Izitsu. There's clearly several ways to make this work, and it'll be interesting to kind of compare a variety of approaches. So definitely share on Discord, and I'll look forward to having a look at the code. So I think I should quit here. I may clean up some stuff before I commit, because there's a whole lot of commented out code. But I'll let you folks go. You don't need to watch me commit. But this does give us a working selector mechanism, and that's cool. And then it's a matter of doing something similar for the recombination, so mutation and crossover. So now that we know how to get parents out of a selector, we will need to have operators, which we will select an operator. The operator will know how many things it needs, so we can pass it this parent selector thing as an argument, and it can ask that parent selector for the number of things that it wants, and then if it borrows it, it'll give it back when it's done, and the next recombinator to use it will sort of pick up where it left off. And then I think we'll be able to sort of make this pretty general, and that would be quite nifty. That would make me very happy. So, yay! You're all awesome human beings. Thank you very much for your time and for participating. If anybody's got any questions, let me know. Reminder that the Discord invite link is over here on the left. If you want to join the Discord, that would be awesome. I will see, it's Wednesday. I will be back Saturday. Should do both streams on Saturday. So the morning stream from 10 to noon Central Time, working on the ice-repos web app. One of these days that'll get somewhere. I actually think we're pretty close to creating the submission page. Hopefully won't be too bad, and then it's a matter of like sorting out authentication, which I may do on the side because there'll be a whole lot of keys and stuff, and then submitting all the archive requests. So we may be actually pretty close, fingers crossed. And then Saturday afternoon from 2 to 4 my time, we'll be returning to the Echo client server project. And I think we're at a point where the main thing to do would be to implement the client. And then I think we'd be in a pretty good place on that one. So thank you all. You're awesome human beings. I see you on Saturday or on the Discord. Ciao.